Finally, let's talk about the inverse property of trig functions. Mostly what we're talking about here is the idea that a trig function and an inverse trig function undo each other. In the same way that if I asked you to take the square root of x squared, you would just get x. Or if I asked you to square the square root, you would just get x. Those operations are opposites of each other, and so therefore they're like undoing each other. If you square root x squared, you just get what was being squared. If you square a square root, you just get what was being square rooted. So the same applies for the trig functions, but you do have to be careful about their domains, because remember, there are only inverses over particular domains for the trig functions. So this little chart is handy because you can use it in order to figure out if your value is going to exist. So this says the sine of the arcsine of x is going to equal x. And that's true if x is between -1 and 1. Then if we reverse it, the arcsine of the sine of y will equal y. That's if the angle of y is actually equal to, or is it within the domain from negative pi over 2 to pi over 2. All right, so using these these rules, let's work through a few of these examples. All right, for example 4, they're asking for the arcsine of the sine of pi over 4. So first you need to think to yourself, can you take the sine of pi over 4? You can, and you would get root 2 over 2. Can you then take the arcsine of root 2 over 2? You can, and you would be back at pi over 4. So the answer here is pi over 4. Looking at example B, looking at the arctangent of -14, we need to figure out, using our little rules here, we need to figure out, is the arctan of x, is x a real number? Yes, 14 is a real number. So if we take the tangent of the arctangent of that real number, we will get that real number. So we get -14. Let's look at example C. For example C, we have the cosine of the arc cosine of 0.54. So using our arc cosine rules up here, for arc cosine x, is x between -1 and 1? It is. So therefore, we can take the cosine of it, and we will just get 0.54. Let's look at example D for the cosine of the inverse cosine of pi. So using our cosine rules again, here we need to know, is our inverse cosine of x, is our value of x between -1 and 1? Well, no, it's not, because pi is greater than 1. So this is undefined because it's not between -1 and 1. So therefore, our answer is does not exist. All right, turning the page. Let's do a couple more. We're going to skip a couple of these. So we're going to skip this one. And let's look at the sine of the inverse sine of 2. We have the same situation here as we just had. The inverse sine of 2, it's not in the domain. So therefore, this does not exist. We can't take the inverse sine of 2, which means that we can't take the sine of the inverse sine of 2. Let's look at G. First, can we take the sine of 5 pi over 3? We can, If we think about it, 5 pi over 3 is over here somewhere in quadrant 4, which means that we would get negative root 3 over 2. If we get negative root 3 over 2, we then take the arc sine of that. What angle would it yield? Well, it would yield this 5 pi over 3 angle, but that's not in the domain of the arc sine. But if we think about what the coterminal angle is, so recall, if I drew this better, we can go all the way around to here, or we could go in the negative direction and get to the same spot. If you go to the negative direction and get to that same angle, you would be at negative pi over 3. All right, let's skip that last one also. So let's do these. Use an inverse trig function to write theta as a function of x. So these are pretty easy in the sense that all you're trying to do is actually solve for theta. And we've done some of these already. So noticing where theta is, I have this unknown and I have this side. So that's the opposite and the adjacent. Opposite and adjacent is tangent. So I'm going to set up my ratio where it says tangent of theta is going to be the opposite over the adjacent. And then I'm trying to isolate theta. The way that you would isolate theta is that you would take the inverse tangent of both sides. So when I do that, this theta and this thing, that ratio, are going to switch places. So I now have the inverse tangent of x over 6 equals theta. That's it. That is, I did it. I wrote it as a function of x because theta is all by itself. So maybe pause the video here and see if you can do the last one. Here we can see that we needed to use the sine function because we have the opposite and the hypotenuse. So we set up our sine function with the opposite over hypotenuse, then use the inverse sine function to solve for the tangent. I'm sorry. Use the inverse sine function to solve for the theta or isolate theta, and that's what you get. So that's your inverse sine symbol. Okay.